Hello, and welcome to day 2 of our chain rule. So here we are, part 2. We're going to make our functions that we're trying to find the derivative of just a little bit more complicated this time around. So we're going to add in some, quotient rule, product rule, along with the chain rule. So here we go. So first example, I've got y equals x squared times the square root of 2x. So clearly we've got product rule here because I have two things being multiplied. I've got the x squared and I have the square root of the 2x. But I also see that I need chain rule because the square root of 2x is a little bit more complicated because there's stuff inside of the square root. So with the product rule, I'm going to start with that because I need to find the derivative of each part. So derivative of x squared is just 2x. The derivative of the square root of 2x is where I'm going to need the chain rule. So the inside part is going to be 2x. The outside is the square root of stuff, which I'm going to rewrite as to the half power because I don't like radicals. Okay, so now applying the chain rule, I need to find the derivative of the outside, leaving the inside the same. So that would be the 1/2 times the stuff in the parentheses, and then subtract the exponent by 1, so I get negative 1/2. And the stuff inside the parentheses stays the same, which was the 2x. Then multiply with the derivative of the inside. The inside was 2x, so the derivative is just going to be 2. Okay, simplifying that down, I end up with 2 over, and then the 2 on the bottom from the 1/2 with square root of 2x, which simplifies, reduces to 1 over the square root of 2x. Cool. Okay. So I've got, this looks kind of crazy. I've got the derivative of the x squared. I've got the derivative of the square root stuff. And so this is when we use the product rule then to do our little cross multiply thing. So it'll end up being y prime equals, I'm going to take the x squared over here and multiply with the 1 over square root 2x. And then add that to the 2x multiplied by the square root of 2x. Okay, so I've applied the product rule now. I just need to simplify this out a little bit to make it look nicer. Okay. There's nothing else to simplify or reduce, so that's my answer. Okay, let's do another example, this time slightly more complicated again. Still product rule though, and chain rule, because I've got 3x to the 4th power being multiplied with another thing, the square root of x squared minus 2x. And then with the square root of the x squared minus 2x, I know I'm going to need chain rule because the stuff inside the square root, complicated. So, again, I'm going to start off with product rule. So the 3x to the 4th power, the derivative would be 12x cubed. And then with the chain rule on the square root, I'm going to have for the inside is going to be x squared minus 2x. For the outside, it's going to be the square root of stuff, which I'm going to rewrite as stuff to the half power. Okay, so derivative of the outside would again be the 1/2 with the stuff raised to the negative 1/2 power, with the stuff on the inside staying the same, so just that x squared minus 2x. And then I'm going to multiply by the derivative of the inside. So the inside was x squared minus 2x, so the derivative would be 2x minus 2. And I'm going to leave that in parentheses because, all that 2x minus 2 has to stay together. Okay, multiplying these things out now using product rule, I'm going to end up with the 3x to the 4th power, that was the original thing I was being multiplied, with the derivative. Oh, I didn't even simplify the derivative yet. Hold on, let's do that. So this will end up being 2x minus 2 on top, 2 square root stuff on the bottom. We can divide everything by 2, so this will end up being x minus 1 on top. And the reason why we were able to divide everything by 2, it's kind of like factoring out of 2. And so that's what caused us to be able to cancel out with the 2 on the bottom. Okay, so from there, the 3x to the 4th multiplied by the derivative over here. So I've got x minus 1 over the square root of 2. Wait, I don't know why I wrote that second 2. So just x squared minus 2x. Oh my goodness. And then I'm going to add the other side of the product rule. So I've got the original square root of x squared minus 2x being multiplied with the derivative of the first thing, which is 12x cubed over here. Okay, oh geez, I got a lot of x's everywhere. Let's multiply some stuff out. So with this first fraction, I'm going to have to distribute that 3x to the 4th to both the x and the minus 1. So this will end up being 3x to the 5th power minus 3x to the 4th power, all over the square root of x squared minus 2x, plus, and then I have 12x cubed. That'll just come before the radical. Okay. There, I think there's nothing else to factor out at this point, so that's our final answer. Looks a little messy, but that's it. Okay, so now let's try one with the quotient rule instead of the product rule. So this time, let's do y equals x over the cube root of x squared plus 4. Okay. So very clearly, I need quotient rule because I've got the fraction. But then I also need chain rule because on the bottom, we've got stuff inside the radical. And again, I don't like radicals, so let me rewrite that as x squared plus 4 raised to the 1/3 power. And then I'm going to find the derivative of the top and derivative of the bottom so that I can use my quotient rule. Remember, low d high minus high d low all over low low. So on top, the derivative is just 1, because it's just an x there. On the bottom, I would need the chain rule. So the inside would be the x squared plus 4. The outside would be all the stuff raised to the 1/3 power. So then the chain rule would require me to find the derivative of the outside, which would be 1/3 times the stuff in the parentheses, and then drop the exponent by 1, which would give me negative 2/3 when I subtract 1 from 1/3. And then stuff on the inside would stay the same. And then I'm going to multiply by the derivative of the inside, which would just be 2x, because the plus 4 is a constant, and the derivative of that would be 0. Okay, simplifying this out a little bit, I've got the 2x on top, I've got a 3, and a cube root of x squared plus 4 squared on the bottom because of the 2/3. Okay, I don't think we can simplify that anymore. So low d high, now we're ready to do our quotient rule. Low d high minus high d low all over low low. Okay, this looks messy. Here we go. So let me just start by multiplying some stuff out, trying to simplify this down as much as possible. So multiplying by my radical by 1, I just end up with the cube root of x squared plus 4 still. And then minus, now I've got fractions, so it's going to be x over 1 times the 2x on top will be 2x squared over that crazy denominator of 3 times the cube root of x squared plus 4 squared. Oof. Fractions on top of fractions, let me tell you. Okay, so if you notice, I wrote the denominator slightly differently. I just wanted to show you that both ways of writing it like this are the same. Whether you have that square on like the outside like I have here or on the inside of the radical like I have down here. They are the same thing. Doesn't matter which way you write it. So just wanted to make sure you saw the difference. So here I've got complex fractions. Nobody likes complex fractions. Let's get rid of it. So remember, the way to get rid of complex fractions is to multiply the top and the bottom by the common denominator. And so the only denominator that I have is this one right here with the 3 and the cube root, all that stuff. So I'm going to multiply the top and the bottom by that denominator. So then on top, now I'm going to have the cube root of x squared plus 4 times another cube root of x squared plus 4 squared. So really that's 3 of them. So if I have 3 of the cube roots, that should cancel out with the radical, which is kind of nice. So that'll leave me with just the x squared plus 4 without any radicals. And then multiplying with the fraction, the denominators will cancel, which then is just leaves me with a 2x squared. And then on the bottom, oh geez, I have a 3 that was in front of the radical. And then if I have that cube root of x squared plus 4 squared, multiplying by another square will really be to the 4th power now. So from here I can just simplify the top. So I've got the distributing the 3, I get 3x squared plus 12 minus 2x squared over all the stuff on the bottom. And in case you are lazy like me, I'm going to stop writing the radical because I can also rewrite that as an exponent of 4 over 3. Again, up to you. You can do it either way. I will just let you choose. But then simplifying the top, I can subtract the x squared terms to end up with x squared plus 12 over 3 times x squared plus 4 raised to the 4 over 3 power. Whew, that was a good amount of work. A lot of simplifying there, but we got it at the end. All right, last example for this part. So this time I've got a function that is a fraction, so I'm going to need quotient rule for sure, but it's the fraction that's being squared. So the two parts to this is that when I do my chain rule, the inside part is going to be the fraction, which is going to be what's going to need the quotient rule, but then the outside is just a regular, like, something squared. Okay, so when I do the chain rule and find the derivative of the outside is just going to be power rule, so it'll be 2 times the inside stuff, which doesn't change, and then being raised to the 1st power when we drop the exponent. But then when I multiply by the derivative of the inside, that's when I'm going to need to do some crazy things. Well, just the quotient rule, not that crazy. Okay, so let me do the derivative of the inside down here. So because we're going to need the quotient rule, the derivative of the top would just be 3, because the 3x, and then the minus 1 is just a constant, so the derivative of that will be 0. The derivative of the bottom will be 2x, the plus 3 is a constant. So low d high minus high d low all over low low. So let me simplify that. This will end up being 3x squared plus 9 when I distribute out the 3 on top. And then distribute the 2x will give me minus 6x plus 2x, because it'll be a minus 2x when I multiply the 2x with the negative 1, but then I have that negative sign in front, so that'll really change it to a plus. Oh, and now it's 6x squared. My bad. All divided by x squared plus 3 squared. So on top I can combine like terms together to get negative 3x squared plus 2x plus 9. Okay, so that's going to be the derivative of the inside that gets multiplied with my chain rule. Okay. Okay. So continuing from there, multiplying all this together, then we'll have on top, I have the 2, I have the 3x minus 1, and the negative 3x squared plus 2x plus 9. And on the bottom, I'm going to end up with x squared plus 3 times x squared plus 3 squared. So really there's 3 of them, so I can write that as a cube. Okay, so at this point I have everything factored. There's nothing that can simplify more. So actually I'm not going to distribute anything else out because that's just extra work. And like we said, we don't need to distribute things out. You can leave it in factored form. So that would be my derivative. Okay, so hopefully that helped you out trying to like manipulate your derivatives using chain rule combined with other rules. It'll be okay. Let's do some practice. All right, thanks for watching. Bye.